Hello everyone. Today we will look at how to install REISE package, Renewable Energy Integration Simulation Engine natively on our local computers. So the first thing, the package, it's from the Breakthrough Energy Sciences. It's used to run simulations, power flow studies in the electrical grid system in United States. So first thing, it is written in Julia, the simulation engine part. So we need to have Julia installed. The version they recommend is 1.5.3. So we'll just get it, maybe silently. So we are downloading Julia 1.5.3. We are going to untar it, and in the opt, so opt folder. So I need a sudo for that, and it's the right one. So we are decompressing it. Now, in order that our system finds it, we may have to update our the bash RC, or I'm using ZSH. So we'll this is the path here. So export the path and pointing it to the bin folder in Julia. So now I source that. So we have Julia 1.5.3 available. So now I'm going to create a Python environment work. I'm going to call it test. If you can just do that, you may have to install the VN package, Python 3-VN from apt. And by the way, I am on Kali Linux system. So now we can activate that .test bin activate. So now we are in that environment. So I am going to make a directory test B, where we will save all or clone all the other packages which is necessary to run the simulations. So first thing, let us now set up Julia. So Julia, the first thing is to activate the package REISE, the simulation engine, which is written in the Julia language. Clone. So we cloned it. Now if you see, we have the package cd REISE. So we find the path. This is where it is. Now we can go to Julia, go to the package manager, square, right hand side parenthesis, the square bracket, the closing one, and add the package. So now it is going to add the package for us. Now we will add the development version as well. Next is to activate the package. And then we instantiate it. So that is done. So once you activate the package, you could see we are already in REISE. And the second thing, one of the things I was having difficulty was with the py call. It was giving me some errors when I called Julia from Python. So I removed what is already there and reinstall. So this is a 1.9 t1.4. so if I add so we see this 9.93. so now let's go backspace and then add and send. We also need the solver for the engine GLPK. If you have Gurobi, you could use that, which is set to be default. Sorry. So it is going to use that. So now we can test it by saying using REISE, and if it doesn't give us any errors, we are good to go. We also need to test GLPK. If it is not throwing errors, we can proceed to the next step. We can now also test if GLPK is we can import GLPK without any trouble. So we have no errors or anything, so we are good to proceed. So now we will install all the required packages so that the REISE simulation engine can be imported from Python. So if we go to here, we have the requirement file here. So let us see what is there. So the first one, the h5py. So that one, the version which is there was giving me errors on my system, so I installed it separately. So we say and we can now go ahead and install the rest of install. Yes. So that is done. So we can now, before I forget, there's an environment variable, the Julia project, which will be useful. So this one can go ahead. Should this one? So we need that. And making sure the path is, I believe, the Julia project environment variable, and then source it so that the packages can find it, the PowerSimData and everybody. So let us now, so we have installed the requirement for the REISE package. So now the next step, we need to run the simulations, the PowerSimData package. So we are going to go to our root and then git clone. So this is the PowerSimData package. So it prepares the input files necessary to run the simulation. So we don't have to do anything. It will do the necessary cleanup, download it if necessary from the server. So let us clone it. So now before we can run anything, so if you go to, we have a requirement again. So we need all the necessary, so we need to install all the necessary libraries. Again, we are installing the libraries necessary to run PowerSimData. So that's all set. And one thing which is necessary is that we need a configuration file, which I have already written somewhere, for the PowerSimData. So this file is we need that one, so that everybody finds where is REISE, how to run the simulations. So this has to be where, so it's test BE. Yeah. And one last thing is to create the one of the things which is important is to create the locations to save the data, and also when the program is run, it creates an execution list and a scenario list, all the IDs, so that you can keep track what is running and which has already run, which has failed, and so on. So this is a final step before we start to do any calculations. So it will ask yes, and you create yes. So it creates a scenario data folder. So now one of the things, rather than coming back and doing it again, it also asks for a raw file directory. So I'm going to create that data raw, and this is the particular example that we are going to run. So now let us proceed to do some calculations. Now we will run some, see if we can proceed with some running some simulations and everything is working. So one of the things is we need an input file which can be downloaded from the Breakthrough Energy website, from the tutorials. So I'll just copy it from that. And then one more thing, the input files when you run the calculation will be automatically downloaded. So I have already downloaded it. If you haven't, it will download in the process of running it. So I'm just, to make it faster, I'm going to copy it from data. So in your case, it is going to do while we run the calculations. So now let us run 3. So we start the Python and we load. So just notice that I am inside the cloned PowerSimData folder. So I percentage load demo question. device. So we have the whole thing here. So one of the I have made some small change the file, especially the time, make it some. So I have set the time like very small range, 1 hour, maybe 2 hours in the interval of 1 hour each. So to make my calculations run a little bit faster, just for the demo purpose. And second thing, in case if you haven't put the solver is GLPK, it will break if you don't have the Gurobi solver, which can be downloaded and used for an academic purpose on a free license. So I'm using the GLPK, which already we have installed or added to the package. So now we can run the simulation and see the progress. One of the errors that I was getting while running this simulation was that there was a demand flexibility parameter which was not finding, and there is a sequence of code in the REISE package to do some checkup. So I got around the error by basically just hashing out a piece of part for some error check. So I'll do that. That's a temporary hack, but after that it started working. So let me do that before we proceed. So I just canceled the running of the simulation because I just remembered that. So what we need to do, we have to go back maybe and then go to, and then we'll go to REISE. So there is something to read. So if you go to this function reformat demand flexibility, this whole sequence of, especially that names, what was happening is this could be the names. When he tries to call these names, since this is empty, it was throwing errors. So it may be due to the version that I'm using. The Python is 3.99, recommending 3.8, and all those things. I'm not sure about that. So this is a temporary hack. So now let's go back to IPython. So now it's already launching simulation on the local machine, so the setup is working at the moment. So we can keep executing the command scenario dot check progress. So it will show. So now the simulation is running on the engine, and the PowerSimData and the REISE engine, they are talking to each other, and it will keep on checking the status. And you can also say print scenario.print scenario status, which will be like running, failed, or analyze in a different stage. So